Okay, good morning, welcome to
FamilyMath205a.
FamilyMath205a. So yesterday I was watching another one of the MoMath videos, and this one was by a woman named Bryna Craw. I think that's how you say her name. And she talked about something called the pigeonhole principle. Her talk was actually about something a little bit broader, about dynamical systems, but she talked a little bit about the pigeonhole principle, and I thought a pigeonhole principle would make for a fun thing to talk about today.
Yeah.
Have you ever heard of the pigeonhole principle before?
Yeah, I think I have.
Okay, how does it work?
So you have a number of pigeons
Okay,
and a number of holes,
alright,
but the number of holes isn't equal to the number of pigeons.
okay.
So there's going to be some holes with 2 pigeons.
Okay, so that's pretty close, and sorry for my cough today. Let's say if we had 4 pigeons, like we have here. Pigeon, 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 pigeon. And these pigeons were all trying to squeeze into 3 holes. The pigeon holes.
Yeah.
It would tell us that at least one hole has more than one bird.
Because the number of holes is less than the number of pigeons.
Right, so they could go in like this, and then whenever this pigeon came in, I would make 2 in that hole. Or they might all just go into the same hole. But it says however they go in, there's going to be one hole that has more than one pigeon. Okay? So what we're going to do is, with snap cubes, could you get some red snap cubes to represent the red pigeon, and some yellow ones to represent the yellow one, and blue ones to represent the blue? That way they're not as bulky. Okay, here's some blue ones.
Should I get some black ones?
Yeah, and some black ones. Ooh, actually, you know what? Let's swap out the black bird for the green bird, since our base is
The bases.
black.
Okay.
Okay.
So
Need a few blue ones and a few green ones. And we're going to make our first pattern. Okay, and let's say we just had 2 birds. What birds would you like to
let's
use?
use the red and the blue.
Okay, so we had a bunch of red birds and a bunch of blue birds, and that's represented by our snap cubes, okay?
Yep.
And I'm going to line them up. And I want you to tell me how many can I line up until I have to repeat some color bird. Okay?
Whoops.
Whoops, sorry. Guess that what you just saw, that whiteboard you just saw might be the last time you saw that whiteboard. Okay, so I got some red birds and I got some blue birds. I want to line them up in a straight line, but I want to know how many I can line up until I have to repeat.
Well, you mean you wouldn't repeat if you were doing this?
Now just repeat a color that I've already used. Sorry.
Well, the maximum you can lay down would be 2.
How come?
Well, you'd have to use 1 of each color.
Okay, what happens on the 3rd one now?
Then you're forced to use either this or this.
Okay.
Because we only have 2 colors of birds.
Okay, so how does the pigeonhole principle help us on this one?
Now, it says that
What are the pigeons and what are the holes?
these are the pigeons and these are the holes.
Okay.
So,
The pigeons are the birds that we have. We have lots of them, right?
yeah.
But the holes are the colors.
There's only 2 of them.
There's only 2 colors. So once I've used 2 colors, my 3rd time through, I have to repeat and use a color now more than once.
Yeah.
So I can only put 2, if I have lots of pigeons of red, lots of pigeons that are blue, I can only have 2 in a row before I have the same color again.
Yeah.
Okay? Ready to go to a more difficult problem?
Yeah.
Okay.
Alright, here we go.